Hello, my dear students. Today, we are solving question 10 from the WASSCE 2026 mathematics exam. At first glance, this logarithm expression looks heavy and intimidating, but we are going to collapse it down into something incredibly simple. By the time we finish our steps, this entire long expression will evaluate to just the number 3. Grab a pen and some paper so you can follow along. For more exam-style explanations exactly like this, QandA at QandAHelp.com is the best place to prepare properly for your WAEC, JAMB, and GCE exams. Solving this specific question is highly valuable because it requires you to use the 3 universal laws of logarithms. Once you understand how to apply them here, you can tackle almost any logarithm problem the exam throws at you. Step 1. Look at the numbers sitting in front of our first 2 logarithms. We cannot directly add or subtract logs when there are numbers blocking the front. To clear those blocks, we use the power law. This law states that if a number is multiplying a logarithm, we can move that number up to become a power. Applying this to our equation, the 2 in front of log 4 moves up to become log 4 squared. Similarly, the 3 moves up to become log 5 cubed. Now we just calculate those powers. 4 squared gives us 16, and 5 cubed is 125. So our new, cleaner expression is log 16 plus log 125 minus log 2. Notice how we haven't changed the expression's actual value, only its form. Converting coefficients into powers is the mandatory first step before combining any logs. Step 2. Let's focus on the first part of our updated equation, where we are adding log 16 and log 125. A common trap here is to simply add 16 and 125. Please do not add those numbers. Instead, we follow the product law. This law tells us that when logarithms are added, we must multiply the inner values. So log 16 plus log 125 merges into a single log of 16 times 125. 16 multiplied by 125 gives us 2,000. Our entire expression now shrinks down to log 2,000 minus log 2. By remembering that logarithm addition requires multiplication, we successfully compressed the largest part of this problem into a single clean term. Step 3. We are left with only one operation, subtraction. To handle this, we bring in our third tool, the quotient law. When logs are subtracted, the law requires us to divide the numbers inside. Applying this to our equation, log 2,000 minus log 2 merges into a single logarithm of 2,000 divided by 2. 2,000 divided by 2 is 1,000. The long equation we started with has now been entirely reduced to just log 1,000. Just as addition turned into multiplication, subtraction turns into division, neatly stripping away the last layers of complexity. We have our single term, log 1,000, but it might look incomplete. There is no base written at the bottom of the log. In WAEC and JAMB mathematics, when a base is absent, we use the invisible base rule. A logarithm without a specified base is always a common logarithm, which means it has a base of 10. To solve this, we express 1,000 as a power of our base. 1,000 is simply 10 to the power of 3. Because the base of the log and the base of the number are identical, they cancel each other out. The exponent, 3, drops down as our final answer, which perfectly matches option D. Identifying these invisible assumptions is how you cross the finish line in standardized math exams. Let's recap what we accomplished. We moved the coefficients to powers, we changed logarithm addition into multiplication, we changed subtraction into division, and we evaluated the final base 10 log to get 3. Quiz time. Evaluate log 100. 10 squared means the answer is 2. Next, log 5 plus log 2. Addition means multiplication, becoming log 10, equaling 1. Finally, 2 log 3. Move the 2 up, giving log 3 squared, which is log 9. Excellent work today. You now have the tools to handle complex logarithms. Remember to subscribe to the channel and rush over to QandAHelp.com for more in-depth practice for your WAEC, JAMB, and GCE subjects.